Hello, I'm Papia. In this problem, we have to find the equation of a tangent line to the curve of a given function, and the function is sine of 8x at the point x equals pi. And then we will have to graph the function and the tangent line using a graphing utility and then check our result. So let's start with finding equation of a tangent line. Now note that it's just a line, right? And how do we write equation of a line? So recall that to write the equation, what do we need? Well, we need a point x1, y1, and we need slope. Once we have those two, what is the equation? Y minus y1 equals m times x minus x1. So that is the point slope form of a line. So let's see what is given to us and what we have to find so that we can write the equation of this line. Notice that this is tangent line, right? So since it's a tangent line, what do we know? One thing we know is the slope of a tangent line is the derivative of the function. Therefore, we can compute slope by computing the derivative of the function, but we have to be specific, derivative at x equals pi. So we have to figure out the derivative and plug in the x value. That will give us our slope. Okay. What about the point x1, y1? Do we have that? Okay. We have to write down the equation of the tangent line at this point that's given right here. So that is the point on the line. So we already have the point. We have x1 is pi and y1 is 0. So we have almost everything. The only thing we need to calculate is the slope. So let's do that. Let's find the first derivative of the function. Function is right here, sine of 8x. How to compute its derivative? Notice that there are two functions actually. There's an outer function, that's sine, and there's an inner function, 8x. And when I say that, that means to compute the derivative, we need to use chain rule. Okay, so remember the chain rule. You first compute the derivative of the outer function, which is sine. What is the derivative of sine? It's cosine. Okay, cosine of what? You keep that function, the inner function, as it is. So it will be cosine of 8x. And then you can stop. You have to now move towards the inner function. Okay, what is the derivative of 8 times x? Just 8. So that's how we use chain rule, and that's the derivative. Now you just plug in x equals pi. So we have 8, that's a constant, and we'll have cosine of 8 times pi. So let's think about it. What is the value of cosine 8 pi? Note that this is even, right? This is even times pi. So you know cosine of 0 is 1, and then cosine of 2 pi is 1, and then every even pi, cosine will be 1 again. So this is 8 times 1, which is 8. So that's the slope. Now that we have slope, we have the point on the line, we can write down the equation. It's right here. So the equation is y minus y1, which is 0, equal to m. M is the derivative, which we just evaluated here. It's 8 times x minus x1. x1 is pi. There you go. So that is the equation of tangent line. You can get rid of this 0 and rewrite it as y equals, you can keep it as 8 times x minus pi, or you can distribute 8, and it will be 8x minus 8 pi. So this is the tangent line. Okay, now let's use a graphing utility to graph the function f and this line, which is supposed to be the tangent line to the graph at the point x equals pi. And let's do it in the same window. Okay, so y1, plug in sine of 8 times x. y2 is 8 times x minus 8 pi, and graph it. Okay, so it at least checks that this line is tangent to the curve. You can see it. But let's check more. So let's use the tangent feature in your graphing utility to check further. So use the tangent feature. Okay, plug in the x value, x is equal to pi, and hit enter. Oh, look, it's giving you the equation of the tangent line. And the equation says, so it says that it's y equals 8x minus 25.13. Well, this is our equation, 8x minus 8 pi. So let's quickly check what is 8 times pi. Okay, so 8 times pi, oh, it is the exact same value, 25.13. So this checks that it's the same equation. So we found the tangent line correctly. So this is the tangent line of the function sine of 8x at x equals pi. Thank you.